and welcome to this higher tier GCSE lesson on Frustums. First thing to do is complete this do now task. Show all the working in your book. Pause the video while you work this out. Okay, let's check the answers. The first one, the volume is 288 centimetres cubed. Secondly, we have 120 centimetres cubed. Thirdly, 256 centimetres cubed. And lastly, 30 centimetres cubed. So today we are looking at knowing what a frustum is and to be able to calculate the volume. So a formal definition, a frustum is the portion of a cone or a pyramid which remains after its upper part has been cut off by a plane parallel to its base, or which is intercepted between two such planes. Essentially that means a cone or a pyramid with the top chopped off, but the top and the base have to be parallel to each other. So a couple of examples here. We have seen a brief example in the cones lesson and in the pyramids lesson. Okay, so let's have a look at an example where if the only information we are given is the radius of the top and the bottom as well as the height of the frustum. Previously, when we've seen these, we have had the height of the original cone as well. So this makes it more challenging. So let's make sure we copy down the working for the example. So the first thing to have a look at is the fact that this can be seen as a small cone removed from the top of a large cone. So we've just got a sketch to the right there with what that might have looked like. We're going to need to calculate the height of the small cone, and therefore we'll be able to calculate the height of what the large cone was. So we're going to use similar triangles. So you can see with the dotted lines that we have got two triangles. They share the slanted side and they share the height if the height is drawn in the middle. So therefore we can say they are similar shapes because one is an enlargement of the other. So we're going to use fractions for this, so whatever the value is for the small cone over the value of the large cone. So for the height of the small cone is h, the height of the large cone is h plus 10. And then using the radius we've got 8 over 12, which simplifies to 2/3. So we can say the size of the small cone in the lengths is 2/3 the size of the large cone. So we're going to use that to work out the height. So we can set them equal to each other because they are in the same ratio. And then if we cross multiply, that means multiplying the numerator on the left by 3 and the numerator on the right by h plus 10. We end up with this, 3h plus 2 lots of h plus 10, which if we expand and solve, we end up with h is 20. So that tells us the height of the small cone is 20 centimetres, and the height of the large cone is going to be 30 centimetres. We know that because we're going to add on that 10 centimetres, which was the height of the frustum. So now we have all the values required to be able to work out the volume. So the volume of the small cone, remember it's 1/3 times pi r squared times the height. So 1/3 times pi times h squared times by 20. I'm going to leave it in exact form for now, so we don't want to round too early on in our question. So we're going to leave it as 1280 over 3 pi. Same with the volume of the large cone. This time we're going to have 1/3 times pi times 12 squared times 30. We're going to leave that in exact form, 1440 pi. So to find out the volume of the frustum, we are going to subtract the small cone from the large cone. And if we round that to 3 significant figures, we get 3,180 centimetres cubed. There's quite a lot of working there. The only bit that's slightly more challenging than what we've looked at before with cones is to work out the height using the similar triangles. You're going to have a go at 3 questions yourselves now. Okay, so make sure you show all the working. You're going to calculate the volume to 3 significant figures for each of them. There is a hint for part B and part C. So pause the video while you work through these. Okay, question A then. So the first thing to do was that height over the height plus 2, the big cone, is going to be the same as the ratio of 3 divided by 6. That simplifies to a half. So now we can sort of ignore the 3/6 part there and just look at cross multiplying with the h over h plus 2 and the half. So the 2 will be multiplied by the h and the h plus 2 will be multiplied by the 1. So we end up with this. If we simplify, we get h is 2. So the height of the small cone is 2, the height of the large cone is 4. Okay, volume of the small cone, so substitute into the formula, we get 6 pi. The volume of the large cone is 48 pi. We'll subtract to get 42 pi, which to 3 significant figures is going to be 132 centimetres cubed. So well done if you managed to get that. Okay, the solution to question B. So this is drawn on its side in comparison to what we've seen before. The working is still the same though. Just notice that you are given the diameters rather than the radius. So in terms of finding the ratio, we can use the diameter, that's absolutely fine. If you've used the radius, you'll still end up with a third once you've simplified. Okay, so when we cross multiply, we get this, and we solve to get h is 1.5. So the height of the small cone is 1.5 metres, the height of the large cone is 4.5 metres. This is the point where it's important that we recognise that we're given the diameter and therefore need to half that for the radius. So when you substitute in, make sure you've got 0.4 squared. So our exact answer in terms of pi is 2/25 pi. The large cone, again, make sure you've halved the diameter to get the radius of 1.2, and that gives you 54/25 pi. Subtract them, and as a decimal answer to 3 significant figures, we have 6.53 metres cubed. Again, well done if you've got this. The third one is a frustum of a square-based pyramid. So this is where you need to make sure you're using the volume of a pyramid instead of a cone. Now, it wants the volume in centimetres cubed. So the hint I gave you was to convert your units first. So you're going to be working with centimetres. Then you'll make sure that you got the conversion correct. If you have done it in millimetres cubed, just make sure you do the correct conversion at the end. Okay, so I've used it as centimetres now. So I'm going to have h over h plus 4.2 is equal to 3.6 over 6, which is 3/5. Cross multiplying, expand the brackets, and we end up with h is 6.3. So that was the height of the small pyramid, and then the height of the large pyramid is 10.5 centimetres. So remember, volume of a pyramid is a third times the area of the base times by the height. This time the area of the base is a square, so we want the area of the square. So that's going to be 3.6 multiplied by 3.6. The volume of the large pyramid, that has a square base of 6 centimetres by 6 centimetres. Subtract them, and then to 3 significant figures, we've got 98.8 centimetres cubed. Again, well done if you've got that. One final question just to finish you off. It is multiple choice, so work it out and you should end up with one of those answers. So pause the video while you do this question. Okay, you should end up with 27.2 centimetres cubed. So well done if you've attempted this challenge topic. That is it for this chapter. Goodbye.